Aloha! In this problem, we're asked to figure out the pressure difference needed to create a certain flow rate of an engine oil. And we are told that the diameter of the tube it's flowing through is 1.8 millimeters. And the length of this tube that it's flowing through is 10.2 centimeters long. And we're kind of suggested the name of the engine oil, which is in the table of viscosities in the textbook in chapter 10 earlier. So you can find the viscosity, which I'll call the Greek letter eta, is 200 times 10 to the minus 3 pascals per second. So that's just also a given quantity because I told you the type of fluid that's flowing through this tube. And what we want to find is the pressure difference, which we'll call delta P, in this tube needed to maintain a flow rate, like a volume per time of 6.2 milliliters per minute. So the way to answer this question is to use Westphal's equation. So this is an equation for volume, of volume per time, this fluid flow rate in terms of the viscosity. So this was an equation that comes from experiments. And I'll just write it down here, P2, or P1 minus P2. So this P1 minus P2, this is the pressure difference that we want to find. And the Q in this equation, which I've written for the textbook, this is the volume flow rate. So we know the viscosity based on the type of fluid we're told it is. We know the length of this tube. We don't know the radius, but we know that the diameter is given. So we can write down R as d over 2. And then we can just do some algebra and flip this equation around because we know that we're looking for this delta P here, which is what P1 minus P2 is. So just using some algebra, we'll rewrite this equation for delta P. So we have the Q times what was on the denominator, 8 eta times L. And then we have pi R to the 4th. And we can convert Q from milliliters. Well, I can just plug this all in. So we can just plug in all the numbers that are given now. We just have to be careful about what units everything is in so that we can get an answer for this pressure difference in pascals, which is a Newton per meter squared. So we want to have all these quantities in standard international, the SAE units. So we have 6.2 milliliters per minute. And you know that in 1 minute, there's 60 seconds. And in 1 milliliter, there's 10 to the minus 6 meters cubed. So that's doing some dimensional analysis. So we get this volume flow rate in terms of meters cubed per second. And we know we just have a factor of 8 here. Eta 200 times 10 to the minus 3 pascals per second. And the length L, we were told in centimeters, 10.2. So we just multiply by 10 to the minus 2 to get that in meters. And we have R is really the diameter divided by 2. You have 1.8 divided by 2, and this is in millimeters. So this is really 10 to the minus 3 meters. And this is also the fourth power because we have the 1 over R to the fourth factor there. So we can just plug all of these numbers into a calculator. So you'll have like a meter to the fourth up here with this meter cubed times meter. And we can cancel out the seconds. So we'll get an answer in pascals, which is a Newton per meter squared. So you plug all this into a calculator, you'll get about 8,200 pascals as the pressure difference required for this flow rate through this tube for this oil at this certain viscosity.